All right, hello boys and girls. My name is Mario Jimenez. I'm a student at WGU. I'm working on my MCSA in 2012 since my focus is on network administration under the IT program. I'm gonna just kind of fire through this document right here. It's gonna contain some links that you'll be able to see right here in the video, which I will also be copying and pasting over to the description when I upload the YouTube video. I'm pretty much just going to read it verbatim. There's going to be some keynotes coming up. So when we get to those sections, I just recommend that you pause the video just so that way you can review it before you really just proceed forward with the video. I'm pretty much going to read verbatim starting from here. All right, so the topic of this video is to deploy a dual purpose native boot VHD and VM-VHD. This is also known as a bootable VHD, and this will be able to dual function as the VHD or VHDX for a virtual machine, hence the topic, dual purpose. So some of the other Microsoft related utilities that will be demoed and explained will be done so in the context of their relevancy for supporting this dual purpose VHD deployment. But I'm not going to do a full exposition on those other utilities, namely their BCDEDIT, the boot configuration data store, also known as BCD store, BCDBOOT, and the commandlets that mirror the utility of DISKPART and DISM, and how they relate in terms of operating with disk partitions and volumes and Windows imaging. So the focus of this walkthrough is to deploy a bootable VHD and then configure it for the dual purpose of hosting the image of an OS for a VHD or VHDX. So however you will find value in this video, whether you intend to do it as a Gen 1, Gen 2 Hyper-V VM, for example, I'm going to be deploying it as a Gen 1 VHD, but for all intents and purposes, I imagine it'll be the same. I didn't test all scenarios considered here. I did, test it with VirtualBox as well, and I just used a regular VHD. I haven't really done a VHDX, but the mechanics of doing so should be the same. Like the core theory should be the same. So before I even really start, I want to thank Dan Stoltz, the IT Pro Guru guy, because he put together this 4-part mini series right here. You should be able to see that little mouse blip right there. That's the link for it. If you want to Google it, all these links that you see right here, right above them, you're going to see like a little title. That's what you would Google if you want to just search for it that way. Otherwise, you could just copy the links. I will be, like I said, pasting these in the description of the YouTube video. So thanks to Dan Stoltz for putting together his, 4-part series on, native boot VHDs, because without that, I wouldn't even gotten off the ground with this. So without further ado, here are those links and the topics. So pretty much all the information that I'm going to be presenting to you was gathered from these resources primarily. That is a typo. So if you're going to Google it, you definitely want to put it that way. But Google will probably catch even if you spell it the right way, Google will catch it and probably get you the right link, because Google is just smart like that. So these sources are what I use primarily for getting this off the ground, in a functional working state. When I reference these, I will be pulling up the PDF printouts that I have of these documents with my own personal notes. So you're going to see a lot of little extraneous information there that you won't find in the actual documents themselves. My notes, like I said, are personal, and they're just what for my own personal library and reference. It just makes things easier for me to access it, as it's relevant, germane to that topic. So when I go back and review these documents for my own personal reference, later down the road after I've memory dumped all this crap, I have relevant information right there. But you can rest assured that my personal notes are gathered from all these. They're just a compilation of the information from all these resources, because sadly, there's just a lot of moving parts to the whole picture here. So unfortunately, Microsoft can't put everything in one place, because that's just the way that they organize their information. So my notes and observations, terms for this technology include Boot2VHD, native boot VHD, and bootable VHD. So you'll see this same technology referred to with those, various titles there. They refer to the same thing, essentially using a VHD or VHDX file to function as a physical disk to host an operating system. So, and what you could use this technology with any of the modern Windows boot managers or whatnot. So you definitely need to, if you're going to be, using, I think, Windows Vista or Windows XP, and you want to deploy this technology, you're going to have to update your boot manager. And there's tutorials out there that do that. I think this one right here kind of goes into that, if I recall correctly. If you're going to be updating to, like from an XP boot manager and you want to use this technology. So, yeah, that's pretty much how it works. It'll, allow the host system's boot manager to handle mounting the VHD or VHDX and expose it as a local disk as though it were a normal physical disk installed in the system. And that'll allow the boot process to access the operating system files located on the VHD or VHDX and boot up the OS like we are all accustomed to seeing from a normal boot up process. All right, so a couple more things here. These are some key differences and similarities, as you see outlined right here, between a BIOS and EFI firmware based system. So the similarities are they both use the same utilities for editing the BCD stores, which is, like I said, the modern boot process for Windows operating systems since Vista / Server 2008. I might be a little wrong. It could be Server 2008 R2, but I'm pretty sure that Vista and Server 2008 use the same type of boot manager. Here are the differences for BIOS. When you're working with a BIOS-based firmware system, the system partition must be marked active. I think that's the same between both, so I don't know why I outlined that as a difference. But a key difference with the system partition on BIOS is that it must have a drive letter assigned to it. Also, the system partition must be the first partition on the disk or the virtual disk, as BIOS is designed to see critical boot files on the first partition. That's just the way that BIOS works. For EFI, the EFI system partition, it doesn't have to be enumerated with a drive letter, and it doesn't have to be the first partition on the disk. I just covered that right there. So those are two things, or those are a few things that, you need to consider depending on what type of environment you're working in. One of the things I'm going to be talking about is BCDBOOT, and this utility is for installing the boot files for each Windows operating system. And the BCDBOOT utility is unique to each flavor of Windows. So that means that it is operating system version specific. So when you deploy a system partition to host a native boot VHD, you must use the specific BCDBOOT utility that comes with the Windows installation. It'll be found in this path right here. There we go. Right there. So Winder is the environment variable / system32. So when you're working with BCDBOOT, you want to make sure that you change directories to that path, so that way it's the local path, and work with BCDBOOT from there. And if you are working in a dual boot scenario, there will be the opportunity for you to work with the wrong utility if the two systems with which you're working are different. So hopefully that makes sense. I mean, I kind of went into a little bit more detail here, but if you hearing it doesn't really make sense now, just kind of just read this and it should make sense to you. Also, depending on the intentions of your use for this technology, the processes for preparing a dual-purpose native boot VHD and virtual machine VHD will vary depending on your virtual environment and your system firmware type, as we already kind of discussed with BIOS and EFI. The process that I use to deploy a dual-purpose Boot2VHD / VM-VHD with Server 2012 R2 in VirtualBox on a Windows 7 host with EFI firmware was vastly different. Like, it was a completely different, like I had to go back to the drawing board many times to get it to work on a BIOS-based system that was using Server 2012 R2 as the host preparation environment, and trying to deploy Server 2012 on the Boot2VHD / dual-purpose VM-VHD in Hyper-V as the virtual environment. So I didn't test anything with different boot managers prior to Windows 7 or beyond Server 2012 R2, for example, Windows 10. And I'm not sure what version of Windows 8 corresponds to, I don't know what the correct counterpart is in terms of boot manager for the Windows 2012 platform. I don't know if it's 2012 R2 or what have you, but that information should be out there. Like, it wasn't relevant to me, so I didn't go out and find out what that information is. But like I said earlier, the core principles, the concepts here that I'm going to be, detailing should pretty much more or less be the same. And hopefully you'll have a solid foundation if you want to use this same technology in a different type of scenario. For example, you want to use VMware or whatnot, or Windows 8 or Windows 10. So another important note is you will actually see me switching between CLI environments when I use the BCDBOOT and BCDEDIT utilities. And that's because there are some bugs in terms of operation, mostly dealing with the expansion and parsing of the arguments that you hand over to the command switches and whatnot. So when you see me do that, I recommend you do the same. Otherwise, you're going to go through what I went through and just fumbling through the process, because it's not 100% compatible for use in the PowerShell environment. So, like I said, it's a dealer's choice there, but I recommend for BCDBOOT and BCDEDIT, since they were designed to originally operate in the command prompt CLI environment, that you just do the same, that you use them in the command prompt environment as well right here. Excuse me for a second, sorry about that. Lastly, there are two steps that I'm just pretty much gonna simulate. I'm not gonna actually show it for the sake of keeping this short. I'm not gonna actually go through the creation of a VHD, since that takes 5 to 10 minutes depending on the size of the VHD. The VHD in question here that I created is like 50 gigs, and I'm not gonna actually go through applying a Windows image to the VHD, because that'll take like I said, depending on the size of the VHD or the image, or just various variables here, such as processor power, memory, etc. That could take some time as well. For my setup, I'm using PowerShell 5.0. If you want to match that, then you want to look for the Windows Management Framework 5.0. This is the KB number right there if you want to search for it by that. I'm going to be demoing it on a BIOS firmware system. I'm using Server 2012 R2 as the host operating system, so that's where you see the support for the storage commandlets that I'm going to be using. I'm primarily going to be demoing all this in PowerShell, since there's tons of literature and probably videos out there using the modern counterparts, or the older counterparts in DISKPART and DISM. The deployed image that I'm going to be using for the native Boot VHD is going to be Windows 7 Ultimate 64-bit. I'm going to be using Hyper-V for the virtual environment instead of VirtualBox, and that's the same scenario right there for repurposing it for use with the virtual machine as well. And I will be performing the majority of the steps in PowerShell 5.0, but I believe 4.0 will still support the same storage commandlets that we will be using. You will also need Hyper-V previously installed if you want to use the PowerShell commandlets for working with VHDs. Yeah, here you can pretty much read that yourselves. Just disclaimer: I don't work for Microsoft. I'm not a Microsoft MVP. Like I said, I'm just a student prepping for my MCSA 2012. So that goes without saying, I'm not an authority on any of these topics, as I wasn't there, at ground zero deploying, engineering these technologies. So if I present something to you guys that's inaccurate, don't crucify me for it. What I'm sharing with you is just my lessons learned from deploying this between two different, environments with different, virtual environments, and between, like I said, between BIOS and EFI-based firmware systems. So I try to leverage only Microsoft, authoritative sources. That is, documents from technet.com or msdn.com. So that way I'm getting information that is endorsed by Microsoft, even though that's, can be prone to error sometimes too. But like I said, I've scoured tons of documents on these topics, so I'm pretty sure, and I've got it working on different scenarios, so I'm pretty sure that the functional knowledge I have should be valid. All right, so let's get to it. All right, boys and girls. So, if you want a walkthrough, the link that you're gonna want to start with, right here, this link right here, that's good for getting the conceptual. Dan, he kind of goes through it. He goes through the paces, but he's doing everything in with DISM and DISKPART and whatnot. So like I said, one of the key differences between my video is that I'm going to be using PowerShell. This is a very good, just, you know, nuts and bolts, no fluff walkthrough, step by step right here. That's the link that you're going to want to use. And then like I said, some of the other sources for the information I'm presenting to you comes from these links right here. All right. So one of the first things that you have to consider is, you know, proper partition setup. Let me see here. Oops. So you're probably accustomed to seeing, you know, some stuff like this. We got the system reserved here. Since this is a BIOS-based system, it has to be, like I said, enumerated with a drive letter. We see the system marker right there, and it's active, right? Primary partition. Here is the partition that's actually hosting the VHD. And what I mean when I say that it's hosting it, it's just when you create the VHD for native boot purposes, it has to be, you have to place it somewhere. It has to be accessible to the machine that's going to be, you know, booting into it, right? So I created a partition that was pretty much the same size as the VHD. So if you create a 50 gig VHD, then you need to create a partition that has enough space to accommodate that 50 gig VHD, right? Makes sense? And you'll see that D drive right there. Bam, all that's on it is the VHD. This is the working dual purpose bootable VHD / virtual machine VHD. But it's not the demo one that we're going to be using for demonstration. Another thing to consider is this is the actual host operating system right here. So the operating system files are located on this partition right here, and the boot files are located on this partition, hence why it's denoted as the system partition. So one of the things that you need to look forward to is when you're setting up your bootable VHD, when you're using it in the virtual environment, its internal partition structure kind of needs to mirror something like this if it's BIOS based, and if it's UEFI based, or excuse me, UEFI or EFI based, then you can expect to see something like this. Again, we got a partition that's hosting the VHD. This is the virtual environment, but if I was to show you the host environment, it's pretty much the same scenario that we're dealing with there. We got a partition in the host environment that's hosting the VHD, but when you deploy it in a virtual environment, it looks as though it's the physical disk. And since it's an EFI based system, it doesn't need a drive letter, and it doesn't have to be the first partition on the disk, right? And just so you know, right here, this disk right here, that's a VHD. It's not an actual physical disk. There we go. If you want to see the actual, there you go. That's the partition hosting that VHD that we were just looking at. Anyhow, so that's just to really drive it home what we could, you know, expect to deal with in terms of deploying this. Here you see I already created the VHD. Like I said, I didn't want to actually make you guys wait through that process. So that's the command statement that I used to create a fixed size VHD, not VHDX. And when you deploy a fixed size VHD, if it's not dynamic, you have to specify the size. You can do it in megabytes or gigabytes. Actually, I think it's more partial to megabytes, and I think I'm a little confused with that because different parameters for working with storage on Server 2012 with the storage commandlets and whatnot, or the Hyper-V VHD commandlets, they take different parameters. But I did find that, you know, dealing with this type of convention right here, the size in megabytes, it was pretty much just universally applicable when I was creating partitions, etc., etc. So I'm not actually going to be recreating all this since I already have it working, but I will be kind of just simulating what I would be typing. And so the first thing that we want to do is you got to deal with a blank disk, right? Or you got to have some kind of free space. Or if you want to deploy the VHD on, you know, some space that you already have available and it's already, you know, a valid volume with an active file system, you could just work with that too. You can pretty much skip these steps. But for people that are deploying it from, you know, from the ground up, this is what you would want to do. So the first thing before even deploying a VHD is you need to allocate some space for a partition on the disk. So the commandlets that you would want to use for that is going to be new partition. Bam. Oh, and if you're not sure what disks are available, just type get disk. There we go. So make sure this is the actual physical disk right here that we're working with. These are that's like some readers or whatnot, so disregard this stuff right here. So what you would type is, new partition. You would specify the disk number that you want to operate on, like I exposed right there with the get disk output. 0, you could assign a drive letter there. And I always picked, I believe, L for lab. And bam, size. You could either use maximum size. If you specify the use maximum size argument, what that'll do is it'll eat up all the rest of the disk space that's available on, for the free space for the disk that you specified right here. When I say right here, I'm talking about this disk number 0. So if I wanted to use all the available free space on it, I would use that. If you just want to allocate, enough to accommodate the size of the VHD, do that. One thing that you want to take into consideration, like I said right here, we have a 200 megabyte, size VHD, right? If you want to allocate some dedicated free space for a system partition, as you'll be seeing, as I'll be going over in more detail later, then you just need to accommodate 350. So you could either sacrifice 350 out of this 200, or you could add it on top. However you want to do it, dealer's choice. So we got the drive letter that we're specifying, and we got the size. I would hit enter at this point, and bam, it would create a new partition. In fact, you know what? Screw it. I'm just going to do it since I have enough free size to do it. Size, we'll do 51, 350. That's, enough to accommodate the VHD with some space left over for a system partition. Then what the output's going to tell you is the partition number that's assigned to it and the drive letter. This is to be expected. So now on top of get disk, you can use get partition. Bam. Partition 5. So what we need to do at this point is we need to assign a file system, and then we need to make this an active partition. However you want to do it. What I think, there's a couple, like I said, there's a couple different ways you can go. You could either cannibalize some space from the VHD for the system partition in terms of considering what you need for accommodating the virtual machines, virtual hard drive, or you could make that discrete, and you could allocate that in the host system. So you'll see. Let's see. So at this point, what we need to do is we need to mount the VHD. Bam. You gotta specify the path. I used okay, so now that this is mounted, this virtual disk that we just created, that I created up there. Oh, by the way, when you create it, you can expect to see something to the effect of this right here. You're going to see a bunch of little O's indicating the progress bar for creating a VHD, and it's the same thing when you're applying a Windows image, as we get into it later. And so when you create the VHD from scratch using what you see right here, if you guys want to see what I'm looking at, these are my personal notes right here. So when I created the VHD, I usually do a fixed VHD scenario. I don't usually do dynamic. This is the syntax right here, Bacchus-Naur form. So this is what I'm referencing off screen and what you're seeing me type over here. We just mounted the VHD. So now it is considered a disk, a local disk, right? So now we see a new disk right here, disk number 3. So the next thing we want to do now that it's mounted is we want to create a new partition. In fact, you know what? Let me new partition. This number 0. Okay. So we're going to create a new partition. Disregard this new partition statement that we did up here. That's kind of extra. I lost my bearings here. So we just mounted the VHD. So we need to allocate a system partition. And what we're doing is we're going to allocate a system partition that's going to be internal to the VHD. All right. So when we use it in the context of a virtual environment, when we're not natively booting into it, like I said, we're going to use it in dual purpose scenarios. We could either native boot into it, or we could boot into it in a virtual machine. So in the virtual environment, we kind of want to mirror the same, structure, disk/volume, partition structure as we do in a normal physical environment. So we're going to mirror this type of scenario, just these two, just pretend that this is one disk right here with an operating system and a system partition. We want to mirror that for the use inside of the VM. So now that we got the VHD mounted, we're going to do a new partition. This number 3, drive letter, doesn't matter. We'll assign that L. Goodness gracious, get out of here. Drive letter L. Size, we want to make sure that the size is smaller than, just to show you guys some flexibility here. I think we could do that right there. 50 gigs. Oh no, the first partition that we want to deploy on it is going to be the system partition. So what we'll do is we'll put the drive letter S and size byte, size, make it 350 megabytes, right? Man. So at this point, we see the virtual disk mounted here. We see the free space. We need to refresh it so that way you can see the new partition that we just created. Come on now. Oh, right. Once you mount the VHD, you have to initialize the disk since the system recognizes it as a new physical disk. Initialize disk. The number of the disk is 3, if you recall. And this is where we specify the partition style. You could either do GUID or MBR. We want to do MBR. Partition style. Bam. Now the disk is initialized, which is the same thing as marking it as online right here in disk management. And then now we can allocate the system partition. Allocating the drive letter S for system, which we will use later. Size. Bam. Now I'm showing you guys what's going on. You could do this in disk management if you want to, but I'm just showing you kind of the way that the new commandlets work. But you see, this is a really great way to learn commandlets as well if you're familiar with more of the GUI interface. So now we see the new partition over here, right? Has no file system, so it's not a valid volume yet. So we're going to take care of that right now. Now, if you're doing this on an EFI system and you opted not to assign a drive letter, you wouldn't be able to use this same process that I'm about to show you right here with this format volume commandlet because it requires a drive letter. I believe that there are some other ways of working with partitions in order to assign a file system to them without using a drive letter, but since I'm accustomed to working with drive letters, I just kind of do it this way. I could be wrong. I can't remember. I remember considering all the options, exploring these commandlets and whatnot, and you could pretty much just assume that the process that I'm showing you guys here is going to be the one that's going to be very similar to what most people are already accustomed to dealing with in terms of the GUI, their experiences with the GUI. So it's going to be a very, very easy to relate, apples to apples type of scenario here. So we just assign the drive letter of S, so we're going to specify that. We need to specify the file system. I wish it would kind of, let's do this here. That way it's kind of more eye level for you guys in the video. Oh, great. File system NTFS. This is the file system label, and I recommend doing this so that way you kind of have a visual aid in terms of identifying the system partition. I would specify something to the effect of, you know, I think what I was doing is, you know, Boot2VHD sys reserved. And next we need to do, if you want to do a full format, this is, you know, like when you're used to working with disks in or volumes and whatnot, volume management in the GUI, you have the option between a quick format and a full format, right? By default, if you don't specify any additional parameters, it's going to do a quick format. That's the default. So if you want to do a full format, you know, rewrite every little sector and bit to a 0, you actually have to specify the full parameters. So be aware of that option. I don't recommend it because it takes longer, obviously, since it's the opposite of quick. If you don't want to be prompted, then you want to enter these two options, these last two options right there. Bam. So now we see over here we have a primary partition. It's mirroring everything that we just specified. Got the new system label, etc., etc. It's NTFS. So now this partition is ready for us to deploy boot files to it later. This is, like I said, the perspective that we see over here is what we would see inside of a virtual machine. The perspective from the host is this. That's, you know, actually go to desktop. This is all the host can see. It can't see inside the VHD when it's not mounted, even though it is mounted. But in terms of when we're considering using this in the native boot scenario, the booting using the system files on the actual VHD itself, you still have to use the external boot manager that's external to the VHD. Let's go back to the boot manager. When we use a native boot scenario, the boot manager is the one that's on the host system. We're just basically going to copy an entry from the BCD store and then apply it to the VHD as well. We're just going to say, hey, we want to use the same boot manager, which is going to essentially be a dual boot scenario, and we're going to point to the operating system files hosted on the VHD, and it'll mount the VHD to access them. That's how native boot works essentially. That's the long and short of it. So now we need to do the same thing. We need to format this partition right here, or the rest of the free space on that virtual hard disk. So disk number 3, drive letter L for lab, and we're just going to use maximum size because we want to use the rest of it. Bam. This is going to pop up if you're not doing this from a purely command line environment, command line interface environment. You'll see that as well, which is what we're used to. You can just click cancel there if you want to just follow along, or you could just do it how you're used to doing it in the GUI if you want. So we need to prepare this partition to deploy a Windows image to it. What we're doing is manually going through the steps of what happens during a GUI-based OS install. Like when you throw in a Windows disk into a system and it has nothing on the hard drive yet, and you boot to the CD or DVD, whatever, this is pretty much what happens. Let's see, new partition. We already did partition. Now we need to format this partition. Yeah, format volume, drive letter L. File system is going to be NTFS as well. New file system label. We're going to put demo B2VHD. And again, like we're not specifying the full argument, so it's going to be a quick format. What? Did I misspell that? I did. There we go. All right, so this is what we expected to see. So now that the partition is formatted, it's ready for us to deploy a Windows image to it. So you could either use ImageX, which is an old school way of doing it, or DISM, which is another more contemporary counterpart. But the new, I wanted to learn the PowerShell way of doing things because I'm pretty sure that's going to be the wave of the future as far as Microsoft, everything, all their support is going to be leading towards that. So that's why I wanted to learn it that way. If you reference the guides that I told you earlier, everything is going to be done in DISKPART and using DISM or ImageX. And just, just so you guys see what I'm talking about, this is just a PDF printout of one of the links that I referenced earlier. This is pretty much what you would see, how to deploy that. And here's my own personal notes on how to deploy a Windows image. So in order to get a Windows image, you just need a WIM file. I have, as you see here, let's go to desktop here. I should have, there we go. This is the contents of the Windows 7 installation of disk or whatever from Microsoft. So I'm basically going to be working with this image right here. And this, like I said, this is, if you go through a GUI-based, disk-based install, it's going to use this installation image. And what this does is when it applies the image, and if you guys are familiar with that process and it reboots, that's when we first boot into this VHD with this, after applying this Windows image right here, it's going to be like that first reboot after a disk-based OS install with the Windows operating system. So it's going to ask you to specify a username for the admin account and computer name, etc., right? It's going to vary based on the operating system, and all modern Windows systems have an install WIM. So I have that available right there. So when we apply the Windows image, we're going to be referencing this file right here. And the commandlet that we're gonna work with is expand Windows image path. Oh, you also need to understand the index. So if you're not sure, what you can do is get Windows image path. And it'll show you all the indexes. And what this each index references a different particular image. So as you can see, index 4 corresponds to Windows 7 Ultimate. So whatever serial or product key you have for whatever version, that's the index you're going to want to specify. So if you have a Windows 7 Professional product key, you're going to want to specify index 3 of this particular image. So you're going to see me specify an index parameter here shortly. It's going to reference the Windows 7 Ultimate product key that I have. Alright, so you're going to expand Windows image, specify the image path. Specify the index like that, and then we have to specify the apply path. The apply path is going to be this partition right here. It's just going to be L://. That's the apply path. So it's going to deploy that Windows image. It's going to apply that Windows image, install that WIM image right there. Bam. So, oh man, that's going to take forever. I'm going to cancel out of this. Oh man. Actually, you know what? Yeah, we'll go. Goodness gracious. I'm going to pause it. We will reconvene after it's done applying this Windows image, okay?